So the first one here, 2.4 times 10 to the negative 13th to the power of 3. So we have to first take the count, the 2.4 to the power of 3. What's that give us? What's that?
I thought that was a 2, not a 3.
So 2.4 to the power of 3 is 13.824. Then we got 10 to the negative 13th to the power of 3. When we take a power of a power, what do? Multiply the powers. So negative 13 to the third is negative 39. Now we have to adjust this. This has to become 1.3824. Because we can only have one non-zero digit in front of the decimal point. The number became smaller or larger? Smaller. So the power of 10 has to become larger. Negative 39 plus 1 is negative 38. So 1.3824 times 10 to the negative 38. Over here, multiplying. We're going to multiply the counts. 3.5 times 2.8, which is, what is it? 9.8? 9.8. And then when we're multiplying exponents, we do what with the powers? Add them. So 8 plus negative 12, negative 4. So if I wanted to do something like this, tell me where to start. Well, you have to do the top first, right? The fraction bar. Well, you do in the parentheses first. And in there, you got to deal with the fraction bar. So you got to do the top first. 10 to the negative 7th times 10 to the third. When we're multiplying, we add powers. So negative 7 plus 3 is negative 4. And on bottom, we still have 10 to the negative 5th. And still all to the power of negative 4. So now we're going to divide in the parentheses. 10 to the negative 4th divided by 10 to the negative 5. When we divide, we do what with the powers? Subtract. So that's negative 4 minus negative 5, which would be negative 4 plus 5, which is 1. So it's 10 to the power of 1. Now I could just put 10 in there, but I'm going to put the power of 1 in there because I have one more step to do. I'm going to take that to the power of negative 4. When I take a power of a power, I multiply. So 1 times negative 4 is negative 4. So 10 to the negative 4. Any questions? I realize there's a few of you still working on the quiz, and that's fine. Please feel free to take as much time as you need. Or if you'll set it aside for a minute, we're going to go over some new material. The packets I handed out, their homework for the next several days are going to be out of that packet, just so you know. So we're going to go ahead and we're going to start looking at measurement. Measurement is something that kind of developed out of a need to communicate, and in a couple of different ways. In the most primitive method, need to communicate between people that are creating things. For example, if you and I are both building something and we want to build them exactly alike, we need some way of double checking that. If we're working in the same room together, we can just go back and forth and mark, set things next to each other and make sure they're the same size. But if you're building it at a different time or in a different place, we need some way to be able to communicate the size of those objects. Also, they needed to record. I mean, if you were buying and selling stuff, if you send something to me and I need to record how much you gave me so I can give you back the same amount later or whatever, we need some way to write that down and record it so that we can keep track of it. Measurement just kind of, so in order to fulfill that need to communicate and record, measurement just kind of developed. We didn't have, it's not like people sat down and said, we need to figure out a way to measurement. They just started doing stuff. They might have taken, like, let's say they wanted to tell you how long this piece of paper is so that you can make a piece of paper the same size. I might take my pen and go, it's 1, 2, 2.5 pens long. Well, that's great until it gets to you and you take your pen and you go, okay, well, I'm going to make 2.5 of these pens. Well, if I go 2.5 of these pens, 1, 2, that's much longer than my piece of paper here. Why was it longer? Why didn't that work so well? Well, because you can see the difference in length between the pens. This pen, the red pen's much longer than my touchscreen pen. So in order to make the measurements work, there had to be two assumptions. One, had to assume that you had one of the things, whatever I was using to measure, you had one as well. And two, the one you had was about the same size as what I was using. So pens and things like that wouldn't work real well because they come in many different sizes. So they used stuff that pretty much everybody had at least one of, and were relatively close in size from one person to the next. And for the most part, it was body parts for the most primitive measurements. So we're going to start talking about lengths today. And we're going to talk about standard units of length to start out with. In the standard system, one of our shortest units of length we use is the inch. Does anybody know where the inch came from? A lot of people think it's on their knuckle. That is approximately an inch on your pointer finger. The inch actually came from the thumb. It's the distance from the tip of the thumb to the point of that first knuckle. That is an inch. So if I were going to measure something like this piece of paper, it would be 1, 2. Notice that motion, by the way, how it rocks back and forth. You ever hear the phrase to inch along? To inch along kind of means that. You rock back and forth moving along. Or an inchworm kind of moves that same way, kind of inches along. So that was the beginning of measurements, is the thumb, is an inch. Then you might think, well, some people have bigger thumbs than others. Yes, they do, but pretty much everybody has at least one thumb. And you got to remember, this was started a couple thousand years ago or more, where people were a lot shorter than they are today, so there was a lot less variation from one person to the next than there is now. But anyway, at some point, King Edward in the 500s declared his thumb and his everything else were going to be the official measurement units of the land. Now, that was a very egotistic, selfish act on his part, but it actually provided for some huge advancements in measurement. So what they had to do is they had to actually come in and they'd take his thumb and mark it down on a piece of wood or whatever, and then go cut a bunch of things that size and pass them out for everybody to use, and everything else got measured. So they ended up, rather than having to use their own thumb or their own whatever to measure stuff, they had this little standard measuring device. And so if I wanted to measure the length of this object here, then I have one of those inches. Now originally, as you saw with my thumb, you just had to take it and you had to move it along and guess where it ended. Now I have a little shadow when I move it on the screen, but when you're moving it in real life, you don't have that shadow. So there's a lot of error that's caused when you're measuring with your thumb or whatever, just by when you move it, the fact that you don't always get it exactly where you don't start exactly where you stopped with the previous one. So now what they were able to do is they were able to take two of them and they could flip-flop them, putting them end to end like that. So they know that when they butt them up end to end like that, they're starting exactly where the last one ended. And measurement became a lot more precise. In fact, they got to a point where they could take a stick and they took those little blocks and they marked off the stick and they numbered it. And that was the development of our first ruler. So now rather than having to take those blocks and count them as they slid them along, they could just hold it up next to this stick that was marked out and measure it and read the number off instead of counting the marks. So King Edward really freed up measurement by making that move. Like I said, it was very egotistical on his part. He didn't intend to do a good thing, but he did. Part of the problem was there were other rulers in other areas about the same time that had the similar idea, and they declared their thumb and their body parts to be the official measurements. And so standard measurement is not standard from one part of the world to another, an inch would be slightly different size. So anyway, another one of the advantages of the standard measurement, there were a lot of units that used to be used that were not necessary anymore. For example, if I wanted to measure the height of my wall back here, what units would I normally use to measure that? Feet. Could I measure that with my foot? I could get to about here with some serious stretching. But to get any higher, I'd have to chop off my foot at the ankle, wouldn't I? Not going to get up there with my foot to measure it. The foot was good for measuring things along the ground because that's where your feet are. For measuring things going up and down like that, they had different units they had to use because you couldn't get your foot way up there. Well, once King Edward declared that his foot was the official unit, now we had that wooden block we could go right up the wall and measure. We didn't have to get our foot up there anymore. So we'll talk a little bit about some of those dead units. But anyway, from the inch, the next largest unit that we're going to use is the foot. And a foot contains how many inches? 12 inches. Now, for measuring a wall, what you most likely would have used is something called a hand. A hand was the width of the hand here at the base of the fingers. It's about 4 inches. It is still used for measuring livestock, horses, sheep, and sometimes cattle. Just because you couldn't get your foot all the way up to the shoulder of a horse, you use your hands. Now, obviously, with standardized measurement, we don't need hands to measure the height of the wall. We can use our tape measure, our rulers. Another unit that kind of died off is something called a cubit. Anybody know what a cubit was? Yeah. If you remember that one. Goes from the tip of your middle finger, or your longest finger, not necessarily your middle finger, tip of your longest finger to the point of your elbow. Now again, back then people were shorter. For most of us, if we measured, it'd be quite a bit longer than that. But it was about 16 inches. It was used by carpenters. Can anybody think of anything in construction that's 16 inches? Yeah, pretty much everything. Your studs, your floor joists, your rafter spacings in conventional style framing. Now the trusses are put at 2 feet, but they used to be 16 inches. Now, almost everything you did was 16 inches apart. And that's what the cubit was, is a construction unit. Just put down your arm and, okay, that's the next stud, next joist, whatever. Larger than a foot, there's a yard. How many feet were in a yard? 3. A lot of people think of the yard as being the length of your stride. And it is approximately a yard, but that's not where it came from. The yard actually comes from the distance from your outstretched arm, outstretched hand, to either the point of your nose or the center of your chest. That is a yard. It was a tailor's unit for measuring fabric. You see them, they'll take the fabric and they'll stretch it out, 1, 2 yards, and then measure it out to be exact. And again, of course, King Edward declared his yard was going to be the official yard and everything else. Now, when King Edward did this, there were not 12 of his inches in a foot, and there were not 3 of his feet in a yard. A couple hundred years later, after King Edward was dead, they adjusted those lengths because they decided, hey, if you measure something in inches and I measure something in feet, it'd be nice for us to be able to tell which one's longer. So they adjusted the unit so that 12 inches did fit in a foot and 3 feet did fit in the yard, so that they could convert from one to another. But it wasn't planned out. It wasn't planned out well. It just, they forced it to be whatever was closest to it, and they made it work that way. But now, as I said, other countries, other rulers had declared they had their official unit, their thumb and their foot and their yard to be the official units of the land. So some countries, it's not 12 inches in a foot when they were still using the customary length. It may not have been 3 feet in a yard. So some of their measurements may have been slightly different. Bigger than a yard, we have things like a fathom. A fathom was 6 feet, approximately 6 feet. It was actually used for navigation for boats. It was 1 fathom was the shallowest water that most boats could navigate through without getting hung up. It was literally the height of the tallest sailor on the ship. They would usually take the sailor, throw him overboard, and when his feet hit the bottom, if the top of his head stuck out of the water, it was too shallow to navigate. I'm hoping they pulled him back up.
Thank God.
I don't know. There's other ones like furlongs, which is an eighth of a mile. That was actually a furlong was the distance that the average horse could run at full speed before it had to rest. Comes out to be about an eighth of a mile, exactly an eighth of a mile now. There is one in there that we're going to use that's not so common called a rod. One rod is 5.5 yards or 16.5 feet. A rod was a shepherd's tool. A shepherd had a rod and a staff. The staff was that little Bo Peep style hook, which for hooking the animal around the neck so you could shear the wool or attend to any medical needs or anything like that you needed to. The rod was a defensive weapon. It was literally just a big stick. And they found a sapling tree, they cut it down and debranched it, and that's what they used for a rod. And I think 16.5 feet, that's a pretty big stick to be swinging. But if you're fighting off a wolf with nothing but a stick, you want a little bit of distance. I'm probably hiding behind one of the sheep saying, here, take the little one. So anyway, how did a rod become used for measurement? Well, let's say Scotty has some sheep and I have some sheep, and they both go down in the valley and are grazing for the day. And at the end of the day, we go to take our sheep home. I say that I had 12 sheep, and Scotty says he had 16 sheep, and there's only 20 sheep down there. Well, at least one or both of us is lying about how many sheep we had. And there was a lot of fights about, whose were whose and whatever. Even if we agreed on how many each of us had, I wanted all the big ones, and I wanted Scotty to take all the scrawny little ones. Yeah, but such is life. With cattle and horses, they settled this by doing what? Branding them, yes. Worked well for cattle and horses because they're short-haired. Sheep had too long of a coat. After their wool grew out, you couldn't see the brand anymore. Second issue, by the way, with sheep is wool is extremely flammable. Maybe not a good idea to put a hot iron next to wool. They didn't have ear tags readily available at that time, so they really had no way of marking sheep. So sheep herding was the origins of land division. So what we would do is we'd find a landmark, like maybe some big rock somewhere, and we just divide it up. Say, okay, I'm going to keep my sheep over here. Scotty, you keep your sheep over here. And of course, inevitably, somebody would whine, well, your pasture is bigger than mine. So we'd measure it out. I'd take my rod, lay it on the ground. Scotty put his down. Then I'd flip mine, bring it over. We'd count 1, 2, 3. Okay, my pasture is 18 rods by 40 rods. Your pasture is 18 by 40. We have the same amount of land. To this day, if you look at a land survey, most of your land surveys are done in rods. It'll say, the corner of this section is 18.5 rods north of this landmark and 37.25 rods east of this landmark or whatever. Your legal descriptions are usually done in rods. So we brought up furlongs, an eighth of a mile. We're not going to use those too much. We're going to jump up to a mile. Anybody remember how long a mile is? 5,280 feet. Anybody remember it in yards? 1,760 yards. Good. Or 320 rods, if you wanted to know. Or 8 furlongs. But anyway, a mile, there's a lot of rumors as to where a mile came from. One of them was the distance King Edward could see out the window from his throne. The best description I've heard of where a mile comes from is actually from the Greek and Roman military. The Greek prefix mil means 1,000. For example, if you look at your taxes, the mill rate is the price you pay per 1,000. The mile was the distance that Greek or Roman soldiers could march in formation doing 1,000 paces. A pace was starting on your left foot, going to your right foot, and back to your left foot. So let's think about that. If you were to start on your left foot, go to the right and back to the left, that's just under 6 feet, probably about 5.28 feet. That's what that ended up being, was 1,000 paces in formation was a mile. So anyway, if we want to convert from one unit to another, like, I don't know, let's say we want to go from 5 feet into inches. Now, most of you have probably used feet and inches enough that you can make this conversion without too much trouble. What is it? 60. How'd you get that? Multiply by 12, right? A lot of you can look at that and say, well, there's 12 inches in a foot. The only thing you got to do is decide whether I'm multiplying or dividing by 12. Well, when you look at it, feet to inches, the units get smaller, so the number has to get larger. So that tells you got to divide by that conversion factor to make the number larger. If you know your feet and inches well enough, that's just fine. But if you don't, we could always do this. We could do 5 feet over 1, and then use a conversion fraction. Remember when we had 3/4? We multiplied by 3 over 3, turn it into 9/12. We said 9/12 and 3/4 have exactly the same value, because what we multiplied by here was 1. We called that a unity fraction. When we multiplied by 1, we could change the appearance, but it does not change the value. Well, we're going to do something similar here. We're going to multiply by a unity fraction. What we're going to do is we're going to put feet on bottom so that they'll cross cancel out. And we want to go to inches, so I'm going to put inches on top. And from my equivalencies, I know that 1 foot equals 12 inches. So now when I do my math, my feet cross cancel out. 5 times 12 inches is 60 inches. 1 times 1 is 1. So it's 60 inches over 1, or just 60 inches. Now here that seems kind of tedious because most of you know how to work with inches and feet well enough you don't need to do that. But what if I give you 99 feet and I ask you to turn it into rods? Well, we haven't worked with rods enough to know exactly how to convert them. So let's start out with our 99 feet, put it over 1. For feet are on top, we're going to put feet on bottom to get rid of them, going to rods. Now we know our equivalency is 1 rod is 16.5 feet. So now the feet cancel out. 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. And we divide that out. 99 divided by 16.5 is 6 rods. We'll look at those conversion factors more as the next couple of weeks go on. Next, we had metric length. Is that?
Wouldn't you go, because the rods is ours.
In metric length, there's only 1 unit of length. It's a meter. Abbreviated with a little m. A meter is actually slightly longer than a yard. It's actually 39.37 inches. Now you ask yourself, wouldn't it made things a whole lot easier? Wouldn't it have made things a whole lot easier if a meter was equal to a yard? And yeah, it would have. We talked about how the standard units weren't standard. Well, the meter is actually equal to a Swiss yard. The Swiss yard was slightly longer than the British yard, the English yard. So. Anyway, the metric system was not a developed system. It was a planned system. We had been measuring with the standard measurements, feet, inches, miles, all that stuff, for hundreds, if not thousands of years. So they knew how those units worked, and they knew their flaws and their weaknesses and their strengths. So when they sat down to create the metric system, they wanted to create a system that was a lot easier to use, didn't have all these awkward conversions like 3 feet in a yard, 12 inches in a foot, 5,200. They wanted to keep it simple. And they wanted, like when we start talking about volume, capacity, and weight, the conversions between capacity and volume and stuff are really awkward as well. So they wanted to make sure those conversions were pretty simple in the metric system. So they did that. They set out to do that. And I think they did a pretty decent job. By the way, does anybody know when the metric system was developed? Most people would say in like the mid-1900s. The metric system was actually developed in the 1890s. So it's been around for 130 years already. So the meter was actually the only unit of length in the metric system. If you wanted to measure something smaller or larger, they used prefixes. Like the prefix deci means 1/10. So a decimeter was abbreviated dm, that's a tenth of a meter. Centi is 1/100th. So a centimeter is abbreviated cm, was 100th of a meter. Milli is 1/1000th. So mm is a millimeter, which is 1,000th of a meter. So you can see here they went every 10. 10, 100, 1,000. As we kept going, we didn't go by tens anymore. We just skipped to the thousands. So we went from 1,000 to 1,000,000, which was micro. A micrometer is abbreviated with the Greek letter mu, like that. Looks kind of like this. Like a U with a long tail or a P with an open top. Now in the medical field was one of the first fields that had to key everything into a computer. There is no mu key on a computer keyboard. So they actually abbreviated MCM for micrometer. So you might see that occasionally, MC instead of the mu symbol. As we kept going smaller, there was nano, abbreviated NM, which was a billionth. You may have heard a lot a few years ago about nanoscience, nanotechnology. All they're talking about is things that are really small. A nanometer is about the size of an atom, so they're talking about building things with individual atoms rather than cutting them down from larger materials. Going the other way, things that were larger than a meter, we had deca. Deca stood for 10. So a decameter was 10 meters. Now dm is already used for decimeters, so for decameters they use dam. Hecto was 100, so a hectometer, HM, is 100 meters. Kilo is 1,000. So km, or kilometer, is 1,000 meters. And then again, they stopped going by tens and they started jumping to thousands. So they jumped from 1,000 up to 1,000,000. 1,000,000 meters is a megameter. Now, little m was for milli, so they used capital M for mega. Capital M, little m, is megameter, or 1,000,000 meters. Now, in practice, of course, the main unit got used a lot. Kilo got used a lot, and milli got used a lot. The other ones didn't get used so much. In fact, in capacity and mass and stuff, they've almost completely fallen by the wayside. As one of you, as Scott mentioned, he hadn't even heard of a decimeter before. In the U.S., centimeters have caught on, mainly because it's the closest unit there is to an inch, and we were so ingrained with inches, we started using centimeters. But in most of the world, it's the meter, the kilometer, and the millimeter, pretty much used for everything. Unless you get really small enough to go to the micro. On the big side, mega only gets used for astronomy. The distance around the Earth at the equator is only 25,000 kilometers. So that'd be only 25 megameters. So it's not a really useful unit on the surface of the Earth, but in astronomical studies, it's pretty useful. The nice thing about our metric system are our conversions are made really simple. You'll see here each spot on the chart, if I move left or right, I'm either multiplying or dividing by 10. When you multiply or divide by 10, it simply moves your decimal point one spot. So if I have 2.9 meters and I'm converting it into centimeters, I look up here on the chart. I'm going from meters to centimeters. From meters to centimeters is 2 spots to the right. Guess what my decimal point does? 2 spots to the right. So it's 290 centimeters. If I have 350 millimeters and I want to go to centimeters, looking at my chart, to get from millimeters to centimeters, I'm going 1 spot to the left. My decimal goes 1 spot to the left. That's 35 centimeters. If I have 350 millimeters, I want to go to meters. From millimeters to meters is 1, 2, 3 spots to the left. So my decimal point goes 1, 2, 3 spots to the left. So 0.35 or 0.350 meters. Make sense?
Yep.
Okay. In the packet I gave you, page 237, 1 through 12, do them all. That's standard conversions. Page 265 in that packet, 6 through 14, do all those. That is your metric conversions. The other sheet I gave you is just a sheet of all the standard conversions, so you have one all in one spot. If you look at the back of that sheet, though, where there's units of area, units of area and volume, I believe.
So 237 will be on 1 through 12.
Yeah. So on that single sheet, there's one or it looks like a misprint. It says that 1 cubic foot equals. It looks like it's 1.728. It's actually a comma. So it's 1,728 cubic inches. So if you correct that on that sheet, that'll save us some issues later if you use that. So I'll give you the last 4 minutes here to get started on that packet. Those 2 sections there, 1 through 12 on page 237 and 6 through 14 on page 265.